Hi everyone. Today we are going to take a look at some exponent rules. So we'll go over the definition of an exponent, look at some of the rules that we can use to work with exponents, and finally we'll take a look at a few examples of how we can use these rules. So to start off, we're going to list out a few exponent rules, and I actually want to start by looking at the definition of an exponent. So an exponent is when we have a number or a variable. The exponent is listed as a superscript, which just means it's a tiny number and it's up above and to the right of the base. So for example, we might have 2, and then the exponent is going to be whatever we have listed up here. So 2 to the third power. So in this case, our base is 2, just some vocabulary, and our exponent is going to be 3. The exponent represents repeated multiplication. So this is kind of similar to multiplication. You might recall that multiplication is just repeated addition. So for example, 3x is the same thing as x plus x plus x. We're adding x 3 times, so we have 3 x's, or 3 times x. Exponents are similar, except we're repeating multiplication. So 2 to the third power is the same thing as 2 times 2 times 2. So we're repeating multiplication of the 2, or the base in this case, and we're multiplying it the exponent number of times, so 3 times. So this is what we mean when we talk about exponents. Next, let's take a look at some of the rules that we have for exponents. First, we have the product rule. If we're multiplying 2 exponents, and we have, or if we're multiplying 2 expressions or 2 numbers, and we have the same base, and we're multiplying, then that means we can add the exponents together. If we have the same base, we can add the exponents. So what this looks like is if we have 2 to the third power times 2 to the fourth power, because we have the same base here, 2 and 2, we can rewrite this as 2 to the 3 plus 4 power. So we can add the exponents. In other words, we get 2 to the 7th power. And we can see this by writing out these exponents in expanded form. So one note is when we write out all of the multiplication, this is what we call expanded form. So here we have exponent form, exponential form, 2 to the third, and then expanded form is when we write them all out. So if we look at 2 to the third, we have 2 times 2 times 2. 2 to the fourth gives us 2 times 2 times 2 times 2. And we're multiplying. So notice we have 1, 2, 3, 4, 5, 6, 7. We have 7 total 2's that we're multiplying. So that's how we end up with 2 to the 7th. In other words, we add the number of 2's we're multiplying. We add the exponents. So that's why our product rule works out. That's why we can add the exponents. But it is important that we have the same base here. It's only when we have the same base that we can do this addition or multiplying. Next, we're going to take a look at the quotient rule, which is similar. Quotient rule. Again, we need to have the same base when we use the quotient rule. For the quotient rule, a quotient is when we divide something. That's when we use the word quotient. So we're dividing. And it's kind of like the opposite of the product rule. Instead of adding the exponents, we will be subtracting the exponents. So for example, if we have 2 to the 5th power divided by 2 to the 3rd power, we can rewrite this in expanded form. So if you're ever unsure, a good step is to rewrite it in expanded form, and then it makes it a little bit more clear if we can multiply or divide. So here we have 2 times 2 times 2 times 2 times 2, all over 2 times 2 times 2. And then notice we can do some division. We can decide whether we want to multiply or divide first. So here we can divide these two 2's, these two 2's, and these two. All of these, when we divide them, we get 1. 2 divided by 2 is 1, 1, 1. So we end up with just 2 times 2. In other words, 2 squared. So what happens here is we took 2 to the 5th over 2 to the 3rd. We can rewrite that as 2 to the 5 minus 3 power. So we're subtracting the exponents, and that's because we have 5 up here, and then we subtracted these 3 from the 5. In other words, we end up with 2 squared for our final answer there. So for quotient rule, same base, we're dividing, we can subtract the exponents. Okay. And we have 2 squared. So next up we have to the 0 power. So what this looks like is if we have a base and we raise it to a 0 power, we always end up with 1. So keeping our base on the previous examples, 2 to the 0 power gives us 1. So anything raised to the 0 power gives us 1. If we had 100 to the 0 power, we get 1. Any variable x, for example, raised to the 0 power gives us 1. So this is a rule we have. Anything to the 0 power is just equal to 1. We also want to take a look at negative exponents. If we have a negative exponent, that means we need to take the reciprocal. What this looks like is, let's say we have 2 to the negative 3 power. We're looking at negative exponents. Our first step is to take the reciprocal. In other words, we flip the numerator and the denominator. And the numerator, when we look at a fraction, the numerator is just the top, the denominator is the bottom. So here, if we have an integer like 2, we can just rewrite that as 2 over 1. So we have a top and a bottom, numerator and denominator. Our first step is to flip it, 1 over 2. And then our second step is to raise it to the positive exponent power. The positive exponent. So we had negative 3, which means now we flipped it and we will raise it to the third power. So we have 1/2 to the third power. And with exponents, we can think about it as applying this exponent. We can apply this exponent to the numerator and denominator separately. So we can rewrite this as 1 to the third power over 2 to the third power. In other words, 1 over 2 to the third power. So we flip our fraction, and then we raise our fraction to the positive exponent power. Another quick example, if we had 3 halves the negative 2, we start off by flipping it, so 2/3, and then we raise that to the positive 2 power. And then we can apply the positive 2 to the top and the bottom separately. 2 squared over 3 squared is 4/9. So we have 2 steps if we have a negative exponent. Take the reciprocal, raise it to the positive exponent power. Okay, one more example, or we have 2 more examples I want to go through. The next one is looking at raising a power to a power. So sometimes we'll run into a situation where we have an exponent like 2 to the third power, and we'll raise that exponent to another power. So 2 to the third power to the fourth power, for example. In these cases, what we can do is we can multiply. So power to a power means that we can multiply the exponents. So in this case, we have 2 to the third to the fourth. This is the same as 2 to the 3 times 4 power, or 2 to the 12th power. And we can see this, again, a little bit more clearly if we write this in expanded form. What I'm going to do first is take our 2 to the thirds and write them in expanded form. So looking at this to the fourth power, we have 4 2 to the thirds that we're multiplying. And I chose a little bit bigger numbers, so it'll take a little bit longer to write these out. Then I'm going to write out all of the 2 to the thirds. So 2 times 2 times 2 times 2 times 2 times 2 And then as you can see, we have 3, 6, 9, we have 12 total 2's that we're multiplying. So we have 2 to the 12th power. In other words, we take our 2 to the thirds and we multiply our 3 2's by 4. So 4 times. If we multiply them together, we get 2 to the 12th power. So any power to a power means that we multiply the exponents. Finally, the last rule that we'll go over is fractional exponents. If we have an exponent that's a fraction, for example, if we have 4 to the 1/2 power, what that means is that we can end up taking a root. So 4 to the 1/2 is the same thing as the square root of 4. In other words, we get 2. And the root that we take is whatever the bottom of the fraction is. So if we have 8 to the 1/3, for example, that's equal to the cubed root of 8. So we have 3 in the bottom, which means we're taking a cube root. And the cube root of 8 is equal to 2 also. So we take the bottom number, the denominator, and that's the root that we're taking. Sometimes we'll be given a fraction with a number other than 1 in the top. In this case, we can split it up using our power to a power rule, so we can kind of work backwards. If we, for example, have 8, or actually let's do 27 to the 2/3 power. In this case, we can rewrite this as 27 to the to the 1/3 times 2 power. So I rewrote it so that we have a 1 in the numerator for our fraction. And then whatever's in the numerator, or 2, I'm writing it separately as multiplication. And then we can rewrite this as 27 to the 1/3 squared, using the power to the power rule that we just talked about. So now we have the cubed root of 27 squared. Cube root of 27, if you put this into your calculator, you end up with 3. You could also think about what, when we multiply it by itself 3 times, gives us 27, that's 3. We have 3 squared, which gives us 9. So we can also use power to a power to split up these fractional exponents. But with these fractional exponents, we are looking at roots. All right, next up, I want to take a look at an example or a few example problems. So here, we're going to look at a few examples of how to apply some of these properties that we just learned. Okay, first off, we have x squared times x to the 3rd power. You could, again, write these out using our expanded form. So x squared times x to the 3rd power. You could also add the 2 exponents. 2 plus 3 equals 5, because we have the same base, x. So x to the 5th is our answer. Next up, we have x to the 7th over x to the 4th. Again, you could just subtract these using our quotient rule. If you're ever unsure, I suggest writing them out in expanded form. And then you can cancel out a few of these x's. Cancel out 4 of them from the top and the bottom. So we end up with x to the 3rd. In other words, x to the 7 minus 4 power. Next up, we have 36 to the 1/2 times 8 to the 1/3. So here we want to rewrite these as roots. So the square root of 36 times the cubed root of 8. Square root of 36 is 6. The cubed root of 8 is 2. 6 times 2 is 12. So 12 is our answer there. Finally, for D, we have 25 to the 1/2 to the 3rd power. So we could multiply these together using our product rule. We could also look at these separately. So first I'm going to look inside of our parentheses. 25 to the 1/2 power is the same thing as the square root of 25. The square root of 25 is 5. So we have 5 to the 3rd power. And 5 to the 3rd power is 5 times 5 times 5, which gives us 125. So that's our answer for D. So applying some of these rules that we learned to a few example problems. All right, finally, I want to take a look at this table and just fill it out and show you some examples of exponential form, simplified form, and expanded form, along with the base and the exponent. So for some of these 1, 2, 3, and 4 powers, I filled them out really quickly. For 2 to the 0, as we talked about before, we end up with 1 for 2 to the 0. Expanded form, we can't really write it out, we'll just write out a 1. For negative powers, as we mentioned earlier, we're looking at taking the reciprocal. So we have 2 over 1 to the negative 1, which gives us 1/2 to the positive 1. In other words, we just end up with 1/2. One way to write this is 1 over 2, the first power. Our base is 2, exponent is negative 1. And then finally, at the bottom here, we have some variable x raised to the n power. So here, in expanded form, we would have x times x times x. And we end up having, we use a curly bracket here to indicate we have n times number of x's. So we have n number of x's that we're multiplying together. Our base is x, and our exponent is n. Okay, so we took a look at some exponent rules, some examples, and then looked at some of our vocabulary here, simplified, expanded, and exponential forms in this video.